All right, now that we've looked at converting between the forms on logarithms and exponential, we're now going to actually evaluate logarithms, and we're going to do this without a calculator. Okay, so this is all mental math. So on number 7 here, we're going to figure out what the log base 4 of 64 is. So what your brain should be doing is it should be thinking, okay, this is asking me 4 to what power equals 64. Okay, so that's what your brain should be doing. Now, do you have to write it every time? No, but if you need to write it, then write it down. So 4 to what power equals 64? Well, if we start counting if we multiply by 4, 4 times 4 is 16. 16 times 4 again is 64. So that means log base 4 of 64 equals 3. Okay, and again, if you have to, you could start by saying 4 to the first is 4, 4 to the second is 16, and so on until you get your answer. Okay, so these are going to be asking us to find the exponent without a calculator. So this is mental math. That means they're going to work out nice. All right, let's try number 8. What is the log base 5 of 0.2? Now, you know that Miss Miller does not like decimals because my brain doesn't work very well with them. So the first thing I'm going to do is I'm going to change 0.2 to a fraction. So 0.2 means 2 over 10, and 2 over 10 simplifies down to 1/5. And by writing it this way, I can more easily see that when I'm thinking about this process, 5 to what power equals 1/5? Well, in order to flip it over from 5 to 1/5, I know it has to be negative. So log base 5 of 0.2 is -1. Okay, so we can have negative exponents. So it equals a negative number. Okay, what about number 9? Log base 64 of 1. So again, you have to think to yourself, well, what am I trying to find? So mental mathing this, we're saying 64, which is the base, to what power equals 1. So what would that be? Log base 64 of 1. Well, anything to the 0 power equals 1. So this would equal 0. Log base 64 of 1 equals 0. Okay, so let's look at number 10. Log base 7 of -49. Now again, we have to think about this mentally. 7 to what power equals -49? Now let's think this through. If I use a negative exponent, like -2, that means 1 over 49. That's not what I have here. If I use 0, I get 1. If I use a positive exponent, I'm just going to have things like 7 squared, which is positive 49. There is no way to get a negative exponent. So using an exponent to get a negative number, our numbers are always going to be positive. So what that means is this doesn't exist. Log 7 of -49 is undefined. Or sometimes we say DNE, does not exist. Okay, this is an undefined value. Okay, so anytime we have a number that is not positive in the argument, the number inside the parentheses must always be positive. If it's not positive, it doesn't exist. Okay, so I want you guys to try number 11. So log base 1/5 of 125. Okay, so go ahead and pause the video and try this one, please. All right, hopefully you're ready for the answer. So remember, you're thinking 1/5 to what power equals 125? The very fact that these are reciprocals of each other tells me I need some sort of negative exponent. So 5 to some negative number is going to equal 125. And that negative exponent, hopefully you figured out, was -3. Because 5 to the third is 125, and then we need that negative exponent to make it a reciprocal, okay? All right, again, if you got that one right, give me a little smiley face so I know you got it. If not, maybe star it so that we know that we need to go over that one. All right, number 12, log base 4 of 32. So again, we start by asking ourselves, okay, mentally, what's going on here? 4 to what power equals 32? That's what we're asking ourselves. Now if I start counting, so if 4 times 4 is 16, 16 times 4 is 64. Okay, that's too far. There's no value base 4 that's going to give me 32. And that's a problem. Like I told you, if it says without a calculator, there's going to be an answer. It's going to be solvable. So what if we were to figure out a smaller value? So 4, there's no way to change 4 into 32. But what if I wrote 4 as 2 squared? Okay, so we've done this before. 2 squared is the same thing as 4. It doesn't change the value. And 32, let's see, 32 would be 2 to the 5th. Because 2 times 2 is 4, times 2 is 8, times 2 again is 16, times 2 one more time is 32. Now this might help me a little more because now I can see, okay, I need these to have the same exponent. So I need this 2 times whatever this question mark is to equal 5. So that question mark would have to be 5 divided by 2. So we can even have fractional answers here. Let's see if that works. 4 to the 5 halves. That means the square root of 4, which is 2, to the 5th, which is 32. So those fractional exponents that we learned before still exist. So log base 4 of 32 equals 5 halves. Okay, so our exponents can be positive, negative, 0, even fractions. The only place we can't have negatives and 0 is in the argument. So when it says log base 4 of something, the of part has to be positive.